So I just wanted to mention a little bit about hydrophilicity. This is an important property of the ceramic membranes. And just to make sure everyone understands what we mean by hydrophilicity, we're talking about the contact angle of water with the surface of the membrane. And it's something that's easily measured, and many manufacturers will report this data. But it's all you do is you simply apply a drop of water to the surface of the membrane, and you observe how if that drop stays intact or how it behaves when it contacts a surface. So at the extreme condition where you have a, ideally hydrophilic surface, the water will spread out and be absorbed into the membrane. At the other end of the spectrum, if you had a hydrophobic surface, that means, it doesn't like water, then the drop doesn't change and no water is absorbed. Next slide, please. So this is just some data from a paper that was published to compare the contact angle for these different membrane materials. Common polymeric membrane materials are like polyether sulfone or cellulose acetate or PVDF. And you can see how the contact angle for silicon carbide and aluminum oxide compares to the polymeric materials. They're dramatically lower. And this explains or helps to explain the reason for the higher flux rates. But by flux rate, I'm talking about the, unit of permeate per area per time. Okay, next slide, please. And so this is just, if anyone wants to read the paper, this information was published in the journal Separation and Purification Technology back in June 2011. And this paper actually concluded that the silicon carbide membrane offers the least fouling because of the compared to titanium, alumina, and the polymeric membranes because of this hydrophilic properties that it has. Next slide, yeah. So in general, the ceramic membranes can be run either dead-ended. Now, by dead-ended, we mean there's no cross flow. All the liquid that's pumped into the tube, virtually all of it will come out as permeate. So you could think of it like a bag filter or a cartridge filter. That's the way what we mean by dead-ended. But in most cases, especially when we're talking about tailings pond water, you need the cross flow mode of operation in order to minimize the fouling and to allow you to run for a long period of time without cleaning. So, as I mentioned before, we're typically operating the membranes at turbulent conditions inside each feed channel. It could be a velocity ranging from 1 to 5 meters per second. And Nick will talk in a short time. Nick Antonopoulos will talk about pilot testing and how we determine, or why pilot testing is necessary in order to determine the optimum velocity. Yeah, so as I mentioned before, with cross flow, you're able to run for a longer period of time and with a higher permeate rate compared to the dead end mode. I would say dead end mode is typically used in cases where there's virtually no solids, like I mentioned earlier, potable water. We have some customers that put the membranes on, spring water, it's already very, very clean. And in this case, the ceramic membrane is like a safety filter. We're not really, it's not a heavy duty separation needed. So a dead end filter is perfectly suitable for that case. But for heavy oil and grease or large amounts of suspended solids, the cross flow mode is really necessary to make this technology practical. Okay, next slide, please. So yeah, so the way these membranes are used commonly is you have the membrane element like we talked about before. And then again, whether it's a Ceramem membrane, CleanSep, or any other type, these are typically operated within a housing. A housing could be a stainless steel vessel. It could be CPVC. It could be, FRP. It depends on the application. That's as a company and most other companies too, most other suppliers, they want to understand, what's the application, what's the composition of the water, and then we use the materials that make the most sense for that particular application. So the housings are put together into a skid, what we call a skid. A skid has a set of housings in series and parallel, and the housings are connected to a pump with valves and controls, and it's designed to process, a certain amount of liquid. And then we might have, for a given installation or for a given system, there could be multiple skids installed. So that, in some cases where have redundancy, so that the entire plant can run 24/7. So even while, let's say, one set of membranes is being cleaned, the other sets of membranes are operating, to allow for continuous production with no shutdowns. So now I'd like to tell you a little bit about a plant we have in Australia. I'm sorry I can't tell you the name of the company, but it's confidential, but it's in Australia. It started up in 2019, and they're running a process to recycle their tailings pond water. And what happened at this plant was that the local EPA, was very strict, and the mine was not able to get access to fresh water, and they weren't able to generate any new wastewater. It would not be allowed. So they went to a solutions company to obtain a water recycling plant that would allow them to reuse the water from their tailings pond. Next slide, please. So here's what the process looks like overall. The water from the tailings pond first goes through a softening process to remove hardness and arsenic, which was particularly high here. And then after the softening process, we're adding powdered activated carbon. And this is to remove an organic acid that's present in the water, which would be very harmful to the RO membranes. So once that water is pre-treated with the powdered activated carbon, then it's going through a Ceramem ultrafiltration system. The Ceramem ultrafiltration system is removing the powdered activated carbon and all of the other suspended matter. Now, anyone who's worked with powdered activated carbon, it doesn't settle very easily or very readily. So with the membrane system, you're able to remove it, instantaneously. And then the Ceramem permeate, in this case, we're adding some anti-scalant, and then it's going to an RO unit. And some people may know, some people experienced with RO may know, the best quality feed, the lowest SDI you can give to an RO unit would be typically from a UF system. So this is a very high quality pre-treatment to an RO unit. That's the way you could think of it. And then that crystallizer is used to take the rest of the water out of the RO reject. So this is, the plant that was installed. This is all tested and developed back in, I think, 2017. The work was done and the plant was installed in 2019. This is a picture of one of the skids. At this plant, there are 3 skids. Each skid has 16 Ceramem membranes on it. And you can see here, all the piping, all the wetted surfaces are in CPVC. And we did that because the customer, it saved the customer money. He didn't need to use stainless steel. It's not a high temperature. It wasn't a chemically aggressive fluid. So we built the entire plant out of CPVC in order to minimize the cost. Yeah, some other, I'm sorry, can we go back to that slide, please? Just the one quick point I'd like to point out here is that in testing the Ceramem membrane or evaluating the Ceramem, the customer looked at other options as well. Looked at a multimedia filter, he looked at the Miselex technology, he looked at using just regular, granulated activated carbon and a UF alone. And so the Ceramem with the powdered activated carbon was determined, after all that evaluation, to give the best performance because it gave the highest removal. And one other point to note here is why ceramic membranes were chosen, because they are so resistant to abrasion. You know, you could imagine the abrasion that might be caused by fine particles of carbon, you know, with a soft polymer surface, membrane life could have been very short. Yeah, next slide, please. So I'll hand it over to Nick.